All right, so chi-squared tests are the tool that we're going to use to learn about the association between two categorical variables. And really, a chi-squared test is just going to build on what you've already learned, which is how to use crosstabs or a contingency table to study two categorical variables. But it's going to allow us to conduct a hypothesis test. So when we have categorical variables, doing an analysis or talking about what it means for two variables to be related or unrelated is a little bit more complicated than when we're dealing with at least one continuous variable. And so our null hypothesis and our alternative hypothesis are going to be harder to concisely state, for example. But we'll get to that in a moment. Let's focus on an example because I think this will help to make things clearer. So we're going to look at some data that we used in our last lecture, the American National Elections Survey from 2016. And even though we're using 2016 data, we're going to focus on a survey question that asks respondents about how they voted 4 years ago in 2012. And we're going to see how that is potentially associated with the race of the respondent. So let's look at a basic breakdown of how people voted. I see there's a typo here. I said 2016. This should be 2012. So this is the basic tab of how people broke down or how people voted. So you can see that the majority of people say that they voted for Barack Obama, but a sizable number said that they voted for Mitt Romney, and about 2% said they voted for other. So let me show you in Stata how I got to this point. I went ahead and loaded the data in before we started, and what I'm going to do is, if you'll look at the original variable that exists in the data set, they actually have some extra categories that we don't care about for our analysis. So they have a coding for missing. When we're looking at our race variable, we'll get to voting in just a moment. And so I want to create a new version of this variable that gets rid of that missing category. And so what I'm going to do is first I'm going to rename the variable to make it easier to work with. And then I'm just going to change the values of that variable to missing if the race variable takes on a value of less than 0, since missing was coded as -9. Now, if I go back and do tab with this variable, you can see that we don't have -9 showing up here anymore. So that's going to help us do our analysis. Now, when it comes to the voting variable, you can see that there's actually a couple of different categories that we're going to want to exclude. So we have people who say they didn't know who they voted for, they refused to tell who they voted for. The question was inappropriate because, for example, the person claimed that they didn't vote that year, which is a big chunk of people. And we also see some people in this other specified as they did not vote. So even though they claimed on prior questions that they had voted, when it came to asking who they voted for, they claimed that they didn't vote. So we want to drop all those categories. We just want to keep 1, 2, and 5, or Barack Obama, Mitt Romney, and other, which is what you saw in my slides a moment ago. So to get to that point, I'm going to, again, rename the variable so it's a little easier to work with. And then I'm going to replace any values that are less than 0 or greater than 5 with a period for missing. And now if we go and do a tab of this variable, you can see the results that we had in our status slides. All right. So now that we have the basic lay of the land when it comes to the data, let's dig into this a little bit deeper. So first of all, in the total sample of all respondents, what we just looked at, we see that 57% of respondents voted for Obama. We want to know whether or not race is associated with who people chose to vote for. And so one way to think about, are these two variables associated with one another, is to think about, well, if they're unrelated to one another, then the proportion of voters who support Obama should be the same for all racial groups, at least in the population. Remember, our sample is just a finite number of people, and we might see numbers that are slightly different in our sample than the population. We would expect to see numbers that are slightly different. But we want to know, well, in the population, is it feasible to think that all racial groups supported Obama in equal measure? A chi-square test is going to help us do that. If race is related to vote choice, if the two variables are related to one another, then the different racial groups will have different percentages who supported Obama in the population. So in our sample, we can see whether or not there's differences and then use the chi-squared test to tell us whether or not those differences are big enough that we can kind of definitively conclude, or at least tentatively conclude, that those differences are going to extend into the population. In other words, we want to know, based on our sample, can we conclude that the proportion of people who voted for Obama versus Romney versus third party is different depending upon which racial group we're looking at. So in Stata, this is the code that we're going to run. If we go back to my do file, I should have that code in there. And let me show you what happens when I run this command. You can see that we have a cross tab here, like we've seen before. You can see that among the Black non-Hispanic respondents, we have 98% support for Barack Obama, whereas among the white non-Hispanic respondents, we only have 48% voting for Barack Obama. So that suggests that there's some difference, at least within our sample. And we could go and look at all the other racial groups and see where those differences also exist for other racial groups. But remember, like I said, these are differences in our sample. We want to know whether or not these differences are big enough that we can conclude that these differences must also exist in the population. Again, there's always random noise, there's sampling error when we have a finite sample, and so we want to know, are these differences big enough that they're larger than what we would expect from just dumb luck if the support was actually equal among the different racial groups in the population? That's what the chi-squared test is going to help us do. So if we want to try to put the null hypothesis for the chi-squared test into words, we would say something like the two categorical variables are unrelated to one another in the population. That's fine if you're trying to summarize a null hypothesis. There's multiple ways we can say it, but that's one. The two categorical variables are unrelated to one another in the population. That's our null hypothesis. Another way we could say this: the breakdown percentages among the three vote choices are equal for all racial groups. In other words, the percent that supports Obama versus the percent that supports Romney versus the percent that supports other is equal for all of those rows, for all those different racial groups. The alternative hypothesis is going to be the opposite, specifically that at least one racial group has a different vote breakdown than the other groups. This is again like the ANOVA that we learned about in the last lecture. Just having one group be different is enough for the alternative hypothesis to be true. We're not necessarily saying that every racial group looks different than all of the others. So in Stata, if we want to get our chi-squared, we're just going to add, this option chi-squared at the end of the command that we ran before to get our contingency table. And now we're going to get a p-value at the bottom of the table. All these results up here should look exactly the same as what we just saw a moment ago, but we're also getting a p-value here at the bottom. Now, anytime we have a p-value, what do we want to do? We're going to compare it to our alpha level, which is usually 0.05. Is this greater than or less than 0.05? It's less than 0.05. So what do we do when our p-value is less than 0.05? We're going to reject the null hypothesis. And of course, we have our null hypothesis written right here. In other words, we're going to reject the idea that there's no relationship between race and who someone voted for. And we're going to conclude that the alternative hypothesis is true, that race is related to who people voted for. So anytime we do a hypothesis test, the most important thing to do is to figure out what the null hypothesis is. Sometimes it's easy to state the null hypothesis. Sometimes, like with a chi-squared test, it's a little bit more complicated to state the null hypothesis. But if we can really clarify, ask questions until we understand what the null hypothesis is, then we should be able to understand the hypothesis test that's being conducted, whatever the hypothesis test is. So anytime, regardless of what the kind of hypothesis test it is, anytime p is less than alpha, we reject the null hypothesis. And anytime, of course, p is greater than alpha, we're going to fail to reject the null hypothesis and reach inconclusive results. For this chi-squared test, the null hypothesis is that the two variables are unrelated, just like we said. And so we're going to, since we have a small p-value, reject the idea that they're unrelated. What do we mean when we say that two variables are related, which is what we just concluded? Well, there's a few different ways we can say that, we can explain that, and we've gone through a couple already. One way we can think about it is that if we know the value of one variable, it's going to help us predict the value of the other variable if the two variables are related. In other words, we can ask the question, if I know someone's race, does it help me guess who they voted for? Well, this data suggests that yes, it does. And so we would say that race and voting choice are related to one another. Let me show you just one other thing from my do file. If we want to try to break down and distinguish between two groups specifically, I can add some if commands to my statement. And now you can see that in my data output, it is only showing two racial groups. Now my p-value is not significant, which means that there's not a significant difference between how Asians and Hispanics are voting. Even though we saw that among other racial groups, when we include all the racial groups together, there are significant differences in how they're voting. And the reason this is not statistically significantly different is because you can see that these percentages, while they differ a little bit, are only about 10 points apart. So that's another example of how we can extend what we briefly learned about chi-squared tests. And that's it for this lecture.